What's up, Johnny? Nice to see you today, my friend. Oops. All right, let's get some Windows under control. Yeah, I'm running a little late because I had to reboot just now. OBS, for whatever reason, would not just refuse to see the camera. I don't know why. Usually I can kind of just unplug, replug, and it's happy enough with that, but got nothing on the camera. But we rebooted. We swapped it back, we restarted OBS, and then got the camera back. We need a browser next, and then what's that? All right. So, yeah. Good morning, welcome, happy Saturday. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually stream around this time each week. Kindly add me on Discord. I'm not going to be adding anyone on Discord. I don't really know you, but you're welcome to hang around and chat on the avenues that are here to chat. Let's do this. Yeah, like I was saying, if anyone doesn't know, my name's Tim. I go by Foamy Guy on GitHub and Discord. I usually stream around this time each week, about 10 a.m. Central Time. We're a few minutes late, like I said, today. But I do usually kick it off around this time, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website here, circuitpython.org. We do have sound. Yeah, OBS has sound. It is basically a version of Python that runs on tiny computers called microcontrollers. Usually the way it works, you plug it into your computer, it shows up like a thumb drive. You can edit a Python code file on that thumb drive, and when you save it, the microcontroller will actually run the Python code for you. And then the code itself can interface with other hardware peripherals that you connect to the microcontroller. There are lots of different microcontrollers, 623 right now that support CircuitPython, and CircuitPython is just one way that you can program them. There are lots of other ways you can program them as well, but CircuitPython is the main theme typically of my stream. Occasionally I venture out of the bounds of that and work on some other completely unrelated stuff, but more frequently it will either be CircuitPython or something on the periphery of CircuitPython. Let me do this real fast, and then we will go and also say thanks, as always, to Adafruit. Adafruit is a hardware and software company based out of New York. They pay a team of folks, including myself, to work on CircuitPython, so thanks to them for doing that. The project is open source. All the code and everything is published on GitHub. Everyone can see it. You can use it for your own stuff. You can port your own devices to support it. All of that is free. You don't have to pay anything to use it or put it on your device or anything like that. And I think, huge thanks to them for supporting open source software in that way, paying people to work on it, including myself. And if you want to help support them and all of the work that they fund for CircuitPython, as well as lots of other open source work, they do Arduino and other open source software as well. One of the easiest ways to do it is by purchasing hardware from them, which you can do at their website, adafruit.com. You can get yourself microcontrollers that run CircuitPython or not. You can get yourself all sorts of add-ons and things to hook up to your microcontroller to make whatever it is that you manage to dream up. All right, so today I am getting back into sort of AI stuff. This was I just wrote my CircuitPython 2026 yesterday. So I was thinking about this. This was one of the main things I mentioned in there, was wanting to get back to this. So I figured it would be good to kind of start getting back into this. So for anyone who doesn't know, RAG is retrieval augmented generation, I think. Which is a technique that's used with LLMs where you essentially look up some extra information. So a typical, user interaction with an LLM is like the user comes and, asks a question, let's say, and then the LLM tries to provide an answer, and maybe the answer is good, and maybe it's not, and maybe it has made up things, and maybe it doesn't. Retrieval augmented generation kind of changes the paradigm a little bit. So the user comes, they ask a question, and then we use a more traditional database lookup to look up text information that is hopefully relevant to the question. And then we feed that text information to the LLM along with the question that the user asked. And how I intend to apply it to CircuitPython is for like examples in CircuitPython specific code. So if anyone out there has attempted to use existing LLMs to write CircuitPython code, they can do an all right job, but they do suffer from this problem where lots of the code they were trained on was either traditional CPython or perhaps maybe some MicroPython. A smaller percentage of the code that they were trained on was CircuitPython. So they do sometimes make up stuff. Sometimes they'll bring in MicroPython stuff. Sometimes they'll bring in CPython stuff. Sometimes they'll just write code that doesn't exist or work at all anyway. With RAG, we can have a database of CircuitPython specific examples and other, supporting text and documentation. And then we can run a lookup against that database. So a user could come and ask something like, write me an example, like write me a script that reads, the pressure from a BMP 680 sensor or something like that, right? And it can go and look up in the database and search for BMP 680, and it's going to find the example as long as that's what we feed it. And then to the LLM, it's going to see the question from the user, but it's also going to see all the stuff it found from the database, which is going to include the actual example from the actual, BMP 680 library or whatever, which is going to make it very easy for it to generate an answer that is actually accurate. Since it was, from its perspective, it was essentially part of the question. It got this chunk of text that was like, here's a BMP 680 example. And then it got this question from the user that was like, please write me a BMP 680 example. And so it's like very easy for it to do that once you give it both things. So that's the high level idea. I started this out a while ago, and I have done a little bit of poking around on it here and there since then, but not a whole lot. But I would like to get back into it, so that's what we're going to do. I think where I left off, I was working on stubs. So I believe that I had it ingesting the examples okay, the examples from the library bundle. But I think the next thing to do was the stubs. That's what I was working on here, stubs example extractor. And this was trying to get the stubs from the core and extract, I think, the examples from those, or maybe even the doc strings and the examples. Okay, so if nothing else, it does look like we can test it for Visual I/O. It does look like it's gonna want I don't know if it's gonna work. I don't think we've built the... Yeah, it doesn't find CircuitPython here. I just have the bundle here. I guess what we'll do is go ahead and just kind of make a sub CircuitPython here where we can build docs. And so part of this is going to be me trying to remember where I was at and stuff. Because again, it's like I have poked on it a few times, but it has been even a couple of weeks since I have poked on it at all. So I don't remember exactly where everything's at where I left off. So we'll get to rediscover that together a bit here. Git clone CircuitPython. We'll do that. I don't know if we need. Remember, if you need all the submodules to build. I think you need. I do think you need some of them. So let's do this. Let's go. Let's just take the Raspberry Pi port and let's just do a make. I don't know if this is gonna work actually. Port submodules. Okay, let's see. Not sure if you need the submodules to build the stubs or not. I don't remember, but maybe you do need something. I also don't. You will need Sphinx or something. We'll see if I'm missing any requirements when I try to run it here in a second. It's is it make HTML is the HTML is the docs. Stubs? Yeah, I think it probably just makes stubs. I think I'm gonna delete this because I just don't need your like Discord name if you're actually still around, friend from Twitch here. But like I said, you're welcome to hang out and chat in the places that are here. But if I'm honest, your first message here seems kind of scammy, so I'm gonna delete it. Figure out how to delete it. Looking great so far. Off. Message. Alright, that finished up, so we can make stubs. Or not. Verbosity steps make. Oh, we need to be back up here. Then we need some more things. I mean, that is the stubs. Oh, okay, that's different name. Got to run out this morning. Sorry, gonna have to catch up on this later. Looking forward to it. Not to distract you, but once you got the RAG approach figured out, you might take a look at training a LoRa to see if that works well or better. Training a LoRa. I'll have to look into that one. I'm not familiar with LoRa, unless you mean the radio thing. To gather from context, probably that's something different. But yeah, I'll definitely take a look at that one. Hope you have a nice day. Well, let's see here. We can this one. It's interesting that this. So I'm trying to make the stubs. And in order to make the stubs, I need to install this. But this is the published version of the stubs. So there's kind of like chicken and egg problem. We need to have the published version of it in order to build it. Seems weird. So it didn't work. What we got now? Let's see. Version. Dist. On set board. Environment. Setup tools. Like pin stuff, it looks like mostly. I mean, we got to the stubs stuff here, and then we got into boards. For why we got so many skipped boards. This might be some of these. I think might be some of the Zephyr stuff Scott's working on. Maybe they're and possible the pins are different somehow. Mapped pin stuff, but then we get to here. Invalid version. Normalize. Justice. Subprocess edited. Try this. I don't know if that's gonna. Did some stuff. Remember if the stubs build is documented? Same error. There's a README, but there's no real. Doesn't really tell you anything about building it. I mean, this looks kind of like none of this relates back to anything in the repo. It's like site packages. Can I build stubs back in the normal CircuitPython repo that I have? So I guess I could just not deal with this and use the other repo. sure wish that it would just work with the one that's inside of the place where we're working, because that's where we have the bundle, rest of the stuff. I thought I saw the same messages go by, but we got so much stuff that it scrolled too far. You know, I assume this is just like I'm missing something, right? Or I have the wrong version of something. Like I have to be missing something, probably. Especially because it's like blank version. So I'm like in the repo. Make. What if I use the other virtual environment? Yeah. Okay. There must be something I'm missing or need to upgrade. I don't know what it is off the top of my head, but that works. We got a successful build. I suppose I could have copied is the other thing we could have done is built from the other one and copied it over, but all right, we got a build. That's fine. I don't care about having to use a different virtual environment for now. We can make peace with that. I would like to try stubs. I want to try this and figure out where we're at here. All right, so we did digital IO, and this is what it extracted. Doc strings, it got this stuff. I don't know, RST double colon. So I think this is code. I think it's looking for RST double colon because of... Go look at digital IO so we can see what it's actually processing here. IO. It basically broke this down, and then I think double colon what it's looking for. Yeah, because yeah, I don't think I'm not sure if we're pulling out this part of it or not. Mostly I think it's pulling out docstring and it's trying to hone in on this to know that this is a code snippet. So indeed it has a couple of code snippets there. Has a code block. And it looks like it went through a lot more stuff. Slide switch. Slide switch from. I don't know where it found that. Oh, it is in here. Okay. Oh, it found it. Oh, okay. It is going through the rest of this code. Well, it's going through all the doc strings, though. Okay, that's pretty nice. That's pretty nice. That's cool. Okay. Although it didn't switch to input. I'm not sure if it would have associated this code example with the doc strings of like what switch to input is. Does it set, you know, like set the pull and then switch to read? Because this is like the human readable description of what it does, which presumably would it be in here somewhere. But yeah, they don't actually have the name of the thing, right? They just have the doc string. Oh, it does have, well, it has the class. These ones have the class. Does this have... Oh, it does. Method. Okay. Yeah. No, this is literal. Hold on. Is it? This is literal. Method. This one. Okay, this is it, I think. Method. So it is gonna have this, I think. So yeah, so this is the doc strings, which includes the parameters and stuff. It actually does include the code block here as well, which is a little awkward. And then method, and okay, so it definitely does have associated what the method is. Okay, that's good. Because that means we would be able to say, like, you could ask the LLM, like, you know, tell me what the switch to input method does or something, right? And it would be able to, you know, have context at least to have a chance of answering correctly without just making something up. Okay. So that seems actually pretty good. Yeah, that seems pretty good. Okay. I think I need to come back to here and re-wrap my head around how to run the whole stack. All right, prompting. So run the collector. And then the chunker. And so what I added was a stubs example extractor. Does the collector... extractors have any other select extractors? We have only a collector, but this has an extract thing in it. Output there's data, collect libraries. I don't think this ended up getting used. I'm not sure. Process libraries, extract examples. So when you run collector, it creates a collector and it calls process libs. Process libs is this one. It looks in the bundles. It loops over all the drivers and helpers. It calls extract first package or module. Which gets a lib name that doesn't get used for anything, and then it calls extract examples, which calls process Python file, does some other stuff. But I think this did not get used. I think the idea here was like it was going to try to fetch libraries as well, and I was like, we're not doing that. We have the whole bundle right here, right? We could just give it all the libraries we want, and it doesn't need to go and like download them or anything. Okay. So right now this does run this collector, but not this one. So I don't know. We need to get this extractor. We need to get the data that this stubs extractor generates in with the data that this thing processes. But this has an output directory, but what happens to that? Is it outputter? And then it's going to put metadata inside of it. Okay. So this is, yeah, type example library. So one thing I don't know, is this like totally freeform? Like we could put anything we wanted here, or is this kind of tuned into this type of data? You know, one thing that would be probably good is to go back and look at this a little bit as well. So most of this, so I'm like feeling around in the dark my way through this. I've never really messed with this stuff before this. So this is like a, oh, Laura, there we go. Nice. Yeah, I'll have to check into that one. I had seen it before, I just didn't remember. Learn guides would be a cool thing to add eventually, especially specific ones like the Essentials Guide. A couple of others would be really good. Maybe even like breakout learn guides for each product or something. I don't know. We'll worry about that later. Automated collection. So yeah, here's where I started from. This still doesn't have the. It's not done yet. So it does have this. Okay. Smart chunking. So then that went into chunking. So it seems like we just need to save metadata files inside of output dir processed, and then under whatever name sounds appropriate, which we're not doing libraries when we're looking at the stubs. Instead, we're doing core modules. So I guess I would say module, or what does it call it in like the official docs? I think that says modules, right? Core modules. Okay. I think what we'll do is module name, source, I guess we'll point to the original place where it was. So in our case, that's gonna be like a PYI file, right? Like CircuitPython stubs, digital IO, init PYI or whatever. Type, we'll say, accidentally ran that, didn't mean to. I don't know what it did. It tried to run the highlighted code only, I'm not sure. Type will be module. File name will be the name. The file. I'm not sure really why both of these are here, honestly, but that's fine. And we just write that, and it's just a little JSON blob in a meta file. Okay. So well, but where does the data go, though, right? Because we have this collector, or we have this extractor. Which can extract one thing at a time pretty good. But then we end up with two lists, essentially. Well, a bunch of lists, actually. Or how many lists we have. There's more stuff. So this is already doing the metadata. Save file? Okay. So I think we would do stub file reading. Look like it's writing, but maybe we would just add here the writing. I'm not sure. It's also not. Does this write? What all does this write? Does it only write the meta file? Content. No. It writes the input file. And then it opens a .meta file by the same name. And then it writes the JSON in that. Okay, so it is saving both. I think we could basically take this, put it somewhere. I mean, we need to return? We're not really returning from this one, are we? This one doesn't really return. I guess maybe I just put the return in to be able to test it. What's up, my friend over on YouTube? My apologies, I don't. Mahir? I probably will not pronounce your name correctly if I try any more than that, so my apologies. But thanks and welcome into the chat over there on YouTube. I think we could just metadata, so content. All right, so we already have content, and then we're already going to end up, like, I presume this is going to modify the metadata inside of here. Yeah, this is going to save the metadata, which is why we ended up with more stuff here. So this is a source type stubs docstring, has an extraction method, extracted example. Is it an example? Yes, some of it is. Some of it's just like stubs. I think we should say type extracted core module stubs, maybe. Core module stubs. I don't know, we'll see. Stubs docstring. Pattern context. Context, I don't know what that's going to be. The docstrings. An example index, I don't know what that's going to be either. Okay, so it is examples is this, it gets appended. So each stub can give you multiple examples. This returns all of them. But if we write, so like, are we gonna actually save this literal list? Because it doesn't seem like this would get saved anywhere. Because here we could add the code that's gonna write these things. But this is just gonna write the raw content. I feel like output data. Actually, I have a CircuitPython data currently, but this would be what it was, I think. And these are raw files. They're like actual literal, this is just the file it pulled out. Whereas these basically all... This got broken down into different ones. This basically took one file and broke it into a bunch of different parts. I think we should ask our friend Claude Code for advice on the best way to sort of save the... It will... The data from the Basically say we have this one that's already doing what we want, the collector. We also have the extractor. We want the extractor to do what the collector's doing also. And I'm not sure if it will end up just... So yeah, I think right now it's breaking it apart, so it goes against this if I understand correctly. And then add it to collector. Okay. Yeah, we'll have to see, but I'm thinking this might have gotten rid of the... Make a one also. So I think this... for one thing. Got rid of the red at least. So does it still... List of dictionaries, examples? I mean, this is still returning examples, which is that big list. I mean, that's still not just individual files. But then it goes through there, it calls save example, which loads context, index, safe context, file name, output stuff, output, open the file, write the content, open the metadata, save the metadata. But it's not like doing anything with that big list of extracted parts, I don't think. So I don't know. It's still generating it, but I don't think it's like it's doing much with it per se. It's ending up just writing the file. Maybe. I don't know. We'll see what it does, I suppose. All right, and then it says we can integrate it with the collector by adding a new one of these. At some point, file path glob, we're going to need to... Maybe that'll actually work. It might have figured out the globbing, the file path handling to find all of them. I was gonna say, at some point, we're going to need to get it to loop over... all of the core modules, right? Like I tested it with digital IO only. Steps, we need to import that. Actually show, that's fine, we know how to do that. I want v1 stubs, v1 import name, self.subs extractor, but it doesn't get it ever. Good. Sure, the output dir has gotten created. Doesn't exist, so I don't. In fact, it's already there. And you know what I need is gloves, actually. Back. Actually, I'm gonna run to the restroom. Sorry, so I'll be back in just a minute. Okay. I think this is not indented. So stubs. And I have a data not, which leads me to believe that I ran it and collected data and then changed the name to keep it, but also be able to collect again. So I think I didn't update the bundle. I guess we could do that real fast. As long as it's a... Right? We want to, if we're gonna build it, we might as well update all the stuff before we build it. Take a minute, but all right. We're towards the end of the alphabet, but I think we still have to do helpers, maybe, because I think, yeah, that was drivers. So now we're into helpers. Go over the halfway point, at least. Wonder if I still need to run update. I might need to run update submodules, but I think it will go quick because this has basically fetched. This has like downloaded the stuff, just not like applied it or whatever. This right. This will go quicker, maybe. I think it would have had to fetch each one of these in here. Hadn't fetched first. Oh, that one didn't update stuff. Okay. So run the collector. No extract all docstring. I think it was kind of expecting them to exist either. That whole making stuff up thing. I think extract all doc streams. We do. Realistically, we probably have to get everything that's used, right? It says one usage. I don't know. Like, did I have any other patterns? I don't have any other patterns. Try without? Okay. Something. Very fast. Yeah. Daily. Got some Python code. Got some metadata. Okay. I would like to get that data back out. So the extractor had other stuff also. Let's look at digital IO. It has a switch to input method example and metadata for that. Has just the base digital IO. Has a blink script, but there's no comment or anything, so it doesn't really know it's a blink script. I thought there was a lot more stuff, wasn't there? A lot more stuff. Oh. I don't think we need this. This is probably filtering stuff out. Of course it is valid pipe. Oh, this is what I was imagining, was checking this, which we don't want to do. Man, it's a shame to lose all of the rest of that stuff. Like, we had had so much more information. Like for digital I/O, for instance, we had the rest of the information about it. It just doesn't seem to be in the data anymore. And go back through. It's same directory and output structure. So some of it, though, we could save as not Python. I mean, this still gets so much more stuff that's just like lost. I think we want to try to keep that stuff if we can. So examples. Where does this get called from? Selector here, but it doesn't catch the result. It just calls that. This gets examples and it calls save example, which creates a unique file name, does an index thing, save context, file name, output file, save the code, save the metadata. So how is this filtering out the doc strings? Because we have like this. These. Ow. Have a method. Have way less metadata. Weird that we have like 0 and 1 and then 11, but nothing in between. Me. Maybe it's 1 1, not 11. Maybe it's like file 1, position 1 or something. Still want to know though, why are we losing all the rest of that stuff? No. Because this gets examples, and then it loops over all of them. It does still say library name, which is wrong. I feel like that should say module instead of library. But I also just don't get where the rest of that stuff goes. Samples is a list. Fine. With 3 things in it. With 3 things in it. Example 0 has all the doc strings. I don't know why it's printing this random. I mean, this must be the only thing, I think, actually. This is just getting printed while it runs, maybe. Doc strings. Hmm. Well, I don't know. Hmm. I kind of want to make like a digital IO dot text or markdown or RST or something. I kind of want like a one that can have human readable stuff in it as well. Full human readable information in the doc strings, such as the not have more space before this F. Doc strings as separate files or include in metadata. Makes it easier to chunk. I want everything easily parsable. Hmm. Okay, let's try option 2. Not sure why the recommended one is option 2 and not option 1, but extract example from stubs. So this time it gets doc strings, goes through them, does some dedenting, does some docstring action there, and then in save has also included the docstrings. But then it talks about chunking. We may need to update the chunking later too. Wonder if it brought these back. We just keep the rest of this? I don't know how much it changed. Changed that much. I'm sure. Like it just added here. It's gonna do that. And then inside of save examples, this one we could pick more of, I think. This one happened inside of here. Okay. Let's run collector. See if we have any more stuff now. I guess in the metadata? Docstring, yeah, okay, so now we have docstrings here. The one thing is it did include 2 copies of it. Because it basically included the full docstring for every example it found, and it found 2 examples. But I mean, it is there now. It didn't add, so what's weird is we added it to meta, but it doesn't actually get saved in the meta file at all. But no. Okay, let's look in Chunker and see if it seems like it's gonna handle those files at all. Because basically the process here, as I recall it, is run the collector and then run the chunker. And then you are ready to do the prompt. But I don't think this chunker Yeah, this chunker is not gonna deal with doc strings currently. We'll go ahead and a 0 chunker, 1 chunker. Hopefully this is complete and not like halfway like the other file. Got all the stuff in it. Alright, so we've run collector, we'll run chunker, and I think it's slower, but pretty fast. Stub module py on docstring 4. So this outputs drag ready chunks JSON. Docstring true documentation. Yeah, it looks like we have, yeah, we totally have docstrings now. That's not the digital IO one. This is something else. Synth IO or Wave or sure, but audio delays. Okay. But we definitely have this now, which looks like the sort of human readable stuff. Okay, so we have a chunks, we have collected. I thought one of these steps I thought was slower, but this chunks build a vector database. Oh, the first time that it runs, it will do this thing with this. It saves it to ChromaDB. Takes several minutes. We had 4,400 here. 40, so we ended up with an extra 400 by doing the doc strings. First time CircuitPython rag, which is from prompt, I think. Yeah. Alright, so for a question to try, what if we said one digital input and one digital connected to a switch, one digital output connected to a LED. When the switch is in position A, the LED should blink. And when the switch is in position B, LED should be off. Write a CircuitPython example. Does this. And then I don't know if it updates automatically or what. These are both the same, so I think I am gonna delete ChromaDB and then run the prompt. I presume that that should recreate ChromaDB, but like that thing said, I think it will take several minutes to do its thing. Yeah, we processed 100 chunks, and we got to get through 4,800. It'll be a couple of minutes. But then the thing is, once you do this part, the next time you prompt, you don't have to do this again. It goes way faster. So, bear with me as we wait for this. Stretch it out. Good time to stretch. Interestingly, it doesn't look like it's saving during the process either, so we want to mess with it. Oh, it is actually, okay. PyCharm hadn't updated. You're nearly a quarter of the way done. What would be other good sources of data? So definitely the Learn guides, I think. A select few of them, not just every Learn guide ever, but like the CircuitPython Essentials Learn guide, the possibly like the Learn guides, the product specific ones. So like, you know, Fruit Jam Learn guide, Feather RP2350 Learn guide. Then it could get pinouts and general information about specific hardware and breakouts and things, right? Like if you have a specific breakout, you know, I think earlier I said BME 680 or whatever, right? And if you ask it about that piece of hardware, it's got all the information that's in the guide potentially to be able to pull from. This was it, right? I was about to say, I think there's even one that's like set up for that, but it doesn't. So it's each page only, I guess. So if we go to single page and then text view, maybe that's a view all. Yeah, okay. So each guide, we can get one big markdown file. So theoretically, we could also ingest a select set of guides, which I think would be useful, ultimately. I'm not going to interrupt what I have running here to try and add it. I wonder, I should have maybe tried, I should have at least tried while the database existed, because I don't know if it would have had, like, would it have had to, it might have only had to do the new 400? I'm not sure if it's, like, smart enough to know what's new and what's not, or what. Not sure how that works. We should have tried. I guess I could still try because I could go back and copy the bundle only one over and I could run it again. Probably won't put you all through that on the stream here, but I'll do that at some point. You're almost halfway now. Yeah, these I think would be good. These would be good. Like I was saying, especially like the essentials. Let's do essential. Full page, text view. It's got a lot of good information on it. Now, one thing that would be tricky is it's gonna Python analog in. Okay. I was gonna say one thing that might be tricky is I'm not sure if how hard it's gonna be to associate like what section is what, right? Like this section is all about analog stuff. All the way down to here where it switches to analog out. So above was analog in, this is analog out. But it would presumably, like, if it was going to break this down, we would want the metadata to reflect, like, this stuff came from this section so that it is associated with, like, what it is. We might need to take another audio out. Kind of interesting. Oh, no. The other one was analog out, not audio out. Duh. Okay. But yeah, I mean, we could basically look for these ones, the double hashtag CircuitPython and the, well, single hashtag essentials, followed by new line, followed by double hashtag CircuitPython, followed by whatever the section header is. And then we could know all the stuff that comes before the next one of those is in that section header with that head. We could save that in the metadata. Because it does get tricked, because we can't just key on the double hashes, right? Because all of these exist a bunch of them. But this thing looks repetitive here. CircuitPython Essentials, so guide name, page name is what that probably is. And then all this stuff, we could look until we get to the next one of those, and we know all that stuff is on this page. Getting closer. I think I'm going to run to the restroom again real fast. While it's finishing up. Okay, 35. Only 1,300 more. Yeah, that is one downside of this process, at least as far as like trying to do it on stream and stuff, is it's this. I mean, I think we've been running close to 10 minutes now. I want to say it was 26 maybe started. So it's slow to iterate on this part of it, so it's perhaps not the best fodder for streams, but like I was saying before, though, the good thing about this is this saves it in a SQLite file in its own weird little arithmetic format that it wants, and then when it goes to look stuff up out of there, it's way faster. So the prompt you can get done in like a minute or two as opposed to 5 or 10, depending on how in-depth your prompt is and what model you're using, what hardware you're running on, and all kinds of other stuff. But I think this is still set to, doesn't actually say, but I assume it's set to let's use OpenAI 20B, whatever. Yeah, TOSS 20B. But one of the cool things about this technique is we can just swap in different models also. So we could test out, are there other local models that happen to be better suited for this once we have the RAG information fed to it. What's that for? Need more stuff here. Abstract code concepts. Yeah, we might need more stuff here, actually. The LED, well, we do have LED. Okay, so it should find LED. Or anything we could put, maybe switch here or button, maybe? It looks like we're going to need more of these. I'm assuming these are kind of how, I'm guessing when the question comes in, when the prompt comes in from the user, I mean, conceptually, it's going to want to break that prompt down, find keywords, and then search the database for the keywords. And I'm assuming this is sort of part of that process, basically. There's probably some stuff we would want to add here. Maybe in addition to these, maybe board.i2c, board.spy. I'm not sure if these are like the keywords or if the keywords are on this side. Not sure exactly which way it goes. Keywords are on the right. Concepts are on the left. Okay, so then it's gonna take the concepts and look through the data to find stuff that is relevant for those concepts. So we would hope, in our case, it's gonna find LED stuff, because that's gonna point it to digital I/O, which is gonna get it the stubs for that, and the doc strings and stuff, which should be what it needs to be able to answer the question I asked for about the blinking and the switch. Which I think is like a relatively easy one to start with. Okay, here we go. So now we have actually prompted the LLM. And I'm not running on anything terribly special hardware-wise. It's like a decent gaming laptop, not laptop, but like a decent gaming computer with a sort of middle ground graphics card. A decent graphics card, but from a couple of years ago. And certainly not like optimized for AI or anything like that. So if I recall right, back when I was using this before GPT-OSS 20B, depending on my prompt, it was like 1 to 2 minutes or so to write an answer for it. And then one thing is right now, it's not showing us while it works. I think it's just gonna like finish and then spit out the whole thing. There is a way, theoretically, you can kind of stream the so like right here when we query it, it's gonna go and prompt and then get the response and only return once it has the response. There is a way you can do this part of it where it's like iterator or whatever. It's kind of streaming results and you can actually watch it write the thing, which makes it feel like it doesn't take as long because you get to see while it's working. But right now we don't have that. Right now it's just going to write the whole thing and then spit it all out to us. And we shall see how well it does. And then I'll probably wrap it up after this. We didn't get super duper deep into it, but I did sort of wrap my head around what all is going on here, what the different components to this are. And we did manage to at least ingest the stubs, as well as the doc strings we added to that as well. Which means actually the extra 400 that we got was, some of that was stubs example code and some of that was doc strings. Maybe. I don't know how that counts. Maybe the doc, because the doc strings went along with the code examples? I don't know. Or if those count separately or not. All right. Finished up, so let's take a look at what it got. Yeah, and then the other thing is like there's a lot of output here, so that's part of why it took as long as it did. If we had enhanced the prompt with like, give me the code only, don't bother explaining anything, probably would have gone a bit quicker, I'm guessing. We have a standalone sketch that does exactly what you asked for. One digital input, slide switch, or any momentary button, wired to slide switch. Doesn't exist, but that's fine. Yeah, could be worse, that's fine. Built-in LED, wired to board LED, that one does exist, so that's good. But it could be a custom pin, like D13, also good, that's correct. When it's in position A, the closed or pressed, it blinks. When it's in position B, the open or released, it's turned off. Here's our Python code, import board, digital IO time. You'll LLM comments, emoji and all. Slide switch on most boards is slide switch. See, I don't think this is true really, but I don't know. I mean, I'm not sure that exists on any board. Another thing we could still feed it, which we haven't yet, is the pinouts for the boards as well. When we build the stubs, we also build a list of boards and what pins are available on them. So we could theoretically feed it that too. But in this case, I'm not sure it would have helped it because we didn't ask it for a specific board, right? I didn't say, I want to run this on a Feather RP2350 or something, right? I didn't give it that. So let's see, change the pin if you want. So yeah, I think we'll give it a pass on that. I think that's still correct enough to count. You would have to change it to run it on a real board, but it's telling you, hey, if you're not using this pin, you're gonna have to change this. So it's at least like it knows that too. I mean, it doesn't know things, but the text it outputted indicates as much. Configure it as an input with a pull-up resistor. Okay, and it's, you know, again, if we had said like, hey, just give us the code, we don't need alternates, we don't need explanations, you know, we could have maybe saved some time and not had, like, there's two different ways to do this. Both of them are, I think, fine, but, you know, you don't necessarily need both ways all the time. Set up the LED, so we have board.led, a digital in-out, that looks good to me. And then here we did switch to input. I think actually you might need to set switch.direction as well. So here it says, okay, I didn't read this very good actually, because it says after the above call you could do this, which, I mean, sure you could, but it doesn't matter because it's already set here. So this would be useless. So yeah, I don't know why it said that, but that's fine. It shouldn't break the code. Even if you did it, it shouldn't break the code. It's a comment, obviously, so it won't, but. So let's see, use the built-in. So this one is output, and it's on LED, which looks good. Blink times 1, on time, off time. Okay, the loop is a little... Yeah, the loop is a little weird. I don't know about that way of doing it, but I mean, it should work, I guess. A little weird. But while true, if not switch, calls blink, passes in 1. So that's just going to loop once. Turn it on, wait, turn it off. Wait. Else, if the switch is true, which would be connected to high, which is closed, then keep the LED off. Then it goes into how it works. So we got this whole explanation. Switch is an input. Keeps it high when it's open. LED is an output, allows you to drive it high and low. Blink turns it off the requested number of times. Doesn't say number of times, but that's fine. Keep the main loop readable. Yeah, I mean, yeah, I don't know. In this case, I think it would have been fine. Just put that in the loop. Debouncing. Telling us about debouncing. Okay. I don't love the sleep debouncing, but debouncer library would be good. Instead of sleep debouncing, I'd rather see it say, like, I mean, like, you could keep a Boolean, right? Like previous value, current value, if previous value different than current value. You could handle debouncing with just variables instead of the library. This is like, yeah, kind of works sort of, depending on how long you hold the button down. It helps a little bit, but it's not really debouncing per se, the same way I think of it. Adapting to other boards. If it doesn't have slide switch, then replace it with your actual pin name. If it doesn't have LED, replace that with your pin name. Use an external one. CodePy. Cool. I mean, that looks good to me. One thing we don't see right now. Text. Prompt. Let's print out the full prompt. Oh, with explanations. I was saying earlier we could tell it not to do that and it'd go faster, but we actually did. We told it explicitly to do that in this case. So, print full prompt. Kind of curious what it gets. I'm just going to rerun it on the same exact prompt. And we should see here. Yeah, okay. So yeah, we didn't have to do any of that. We didn't have to do any of that stuff. We got right to the question, and then it was like, here's the full prompt. So that's what we added. Based on these examples, example 1. Oh, there's where it got slide switch. Fair enough. All right, we won't hold that against it for sure then, because it did find it in the code, it looks like. We have, yeah, it's like example 1 is setup, example 2 is got setup, example 3, button pins, there's got into seesaw action, which is a little off the rails, but okay. So those are that's what it pulled out of the RAG system, essentially. And then it has the question from the user. And so it gets to consider all of this context when it's writing the answer. So I will say one thing it does not include in here, though, is the overall digital, like the doc strings, right? Like what is digital I/O? It doesn't include that in the context. A little wonky as well. Okay, but this is the seesaw one, yeah. Interesting. This would be called digital I/O instead of. Well, maybe it has in/out side of it. This is just button. Yeah, it's weird that this is called digital I/O instead of not digital in/out like the core module one. But I don't know. Okay. Cool. Yeah. So I mean, we definitely pulled in. We definitely got the stuff from the stubs, because this stuff came from the stubs. We saw that in the digital I/O PYI file. Maybe this is on the thing. Maybe this is on maybe this is on one. Isn't there a Trinky with a slide switch? But that would probably be analog, would it? I don't know. I don't know. Okay. Don't necessarily need to wait for it to finish the output. I mean, well, theoretically, it'll be something very similar to what we got before, perhaps tweaked a bit, but. Cool. Okay. This is cool, though. We got stubs being ingested. We technically have the doc strings in there somewhere. It doesn't seem like, at least in this case, that it made use of the doc string part, but we know that they're in there somewhere, very least. Well, they're in the collected data. I suppose we don't know too much about the chunked or the vectorized database data. It might be interesting to go look in that SQLite file. I wonder, it probably wouldn't make any sense. Probably a bunch of math stuff. Some stuff doesn't make any sense if you don't have any idea about the math behind it, like I don't. Weights or whatever. I wonder if we asked it, like, can you tell me what the digital I/O module does? Like, can you explain to me what the digital I/O module does and what it's used for. I wonder then if it would include that docstring context. All right, there's our answer finally. The explanation definitely took quite a bit longer. But this time it did not break out the blink into another function. And it did not include that, well, this time I would say it was more correct, in fact. Like, this part is more correct than what it wrote last time. Because it's saying, it says also. So, I mean, really it's either or, right? You could do this, or you could do this and this. You don't really need both. Used a different period this time, half a second instead of 0.2 seconds, and it didn't break it out into that blink function, which is like, I thought the blink function was kind of weird anyway. And it toggled. That's cool. So state equals not state, then sleep. That'll keep going. Otherwise here, when the position B, off, sleep, I don't know. Honestly, you probably wouldn't want to do this necessarily because you want to pull that button again relatively quick if you can. So you could either lower this or not have the sleep, and I think it'd be fine. Let's try this one, and then I think I'll probably wrap it up after this. Although the prompt is going to be weird, right? Because it says solution. Then it also says examples. Example 1, chunk type code. I'm not sure that that's actually going to get the doc strings. Let's try it, though. Tell me... So... for CircuitPython, can you tell me what the digital I/O core module does and how to use it? Basic. Not sure if this will help it or not, but I'm gonna try. Oh, nice. It did. Yeah, it totally did. Look at that. Yeah, okay. Sweet. So it is able to pull those doc strings as well. It doesn't, it's labeling them a bit wrong. It calls this a complete example when it's actually a doc string. It's got some examples in it, but it is not exactly an example per se itself. Actually, and it's duplicated it as well because of the way we had two of them, I think. But yeah, it looks, I mean, I would assume the answer is going to be pretty good. I mean, it looks like it's gonna consider this stuff, so we'll give it a minute, let it see what it comes out with, and then I think I'll probably wrap it up after that. Let's check in on the and everything. No, I got nothing there. Okay, all right. Might be interesting as well to do some compare and contrast at some point, like prompt the LLM with no RAG system, get an answer, and then prompt the LLM with the RAG system, and then compare how the different answers come out. Make sure that we're actually getting you know, more factual answers essentially. I wonder if saying solution here will throw it off, because at this point we're asking kind of just for info and an example, I guess, but not like directly for a specific kind of example like we did the first time that does this and this and this. Instead, it's like, tell me about the module and then show me an example, and it's gonna choose whatever example it wants. Probably basic blink or something, I'm guessing. That'd be the most logical answer, I think. The most logical choice, at least. Or the choice that a human would be likely to make, I think. Given the same prompt. Without any more information about the person's, like, skill set. Like, Blink is the easiest digital I.O. example, for sure. I mean, this is good, though. This means that the digital I.O. lookup managed to work correctly. It would be good still to try some other ones, because we had digital I.O. in this list. Although we didn't say this at all. I mean, somehow it did still find it. I wonder if we pick a core, like bitmap tools, for instance. Bitmap tools is not represented in here at all. I wonder if we pick a module like that, and then we check the full prompt context, is it gonna have stuff, the doc strings in it or not? Okay, so here's our question. So what digital I/O module does? Digital I/O is a core module that gives you a very small but powerful interface to the microcontroller's GPIO pins. What you can do and how it works. Set a pin as an input or output, direction, right, high or low, true, false. Read the current state of an input, enable pull up or pull down resistors, release the pin with D init. Intentionally lightweight, does not provide any of these things or other peripheral. Low level digital building block, that all higher level things like bus IO, motor and stuff are built on top of. I'm not sure. I don't think that's true for bus IO. Motor, I don't know about. Bus IO, I think, is its own thing, though. I don't think it's like making digital IO instances inside there, but not sure. Like conceptually, sort of in a way, but I think not literally. Not sure. Fully commented, ready to run example that turns the built-in LED on and off every half a second. The Blinky demo, even got the name of it. Reads the push button and prints its state, demonstrates both manual and context manager ways to cleanly free the pin. On boards that those, you can use those names. If you need a custom pin, replace it with your thing. And it's pretty good about choosing digital pins and stuff and knowing the right way to call them as well. LED is set to an output, while true, blink, gracefully exit. This one is just output only. Y init, or D init rather, when it's ending you want to do that. Reset the button with a pull-up. Oh, read the button with a pull-up, excuse me. We have a button, direction, input, pull up. Oops. Okay. While true, if not button, the button is pressed. If else, rather, button is released. Sleep, note, pull up pulls the pin high when nothing is connected. The button pulls it low. Button value using a context manager. So we get another example here with digital I/O as LED. This one I'm not sure if I don't know if this works exactly. And I'm especially not sure how it got this based on the context, right? There was nothing in. Yeah, there's nothing in. Oh, well, there's context managers. Okay. Okay. That's actually kind of impressive. It managed to extrapolate from, you could either call the dinit or you could use the context manager, and then it says cref here, but the LLM that we just ran did not have the ability to actually follow that. So it can't go and find, or it didn't, at least, I don't know whether or not it could, but it didn't go and find the actual context manager examples. So it managed to put that together without actually having a literal example, which is pretty impressive, really. If it works, which it looks to my eye like it would, but I haven't tried it. There's a custom pin example. Here's a summary. That's all there is to it. Once you're comfortable with that, you can layer on more stuff. Nice. Yeah, pretty good, I think. All right. I think I'm going to call it a day for now. Thanks to everyone who watched along. I hope you all have a good rest of your day. Had fun watching this. Learned something, perhaps. I know I learned a lot. So I'll keep hacking away at this. I think this is going to be really cool to get a local LLM system that's like suited well for CircuitPython. I think this will be a cool thing to have and a helpful thing at the end of the day to offer people. So I'm excited to keep working on it. I should be back next week. I'm pretty sure normal time, 10 a.m. Central Time or thereabouts on Saturday, 24th. Until then, so long, farewell. Thanks for watching along, and I will see you later.